So we've been hearing a lot. I don't know about you guys, but I've been hearing a lot about these engaged developers throughout this conference in at least 4 topics, including the one right before this. They're these mythical species of creature that apparently does very good work and has a lot of fun doing it. So this is sort of a case study. You have some specimens here before you. We are very happy, engaged developers doing day-to-day work, and we're going to share some of the things we've done in the past year, some of the positive results that we've gotten, and sort of really try to tease out some of the ways in which we have shifted our culture to a bit of more of a DevOps approach and gotten some positive results from that. So I am Greg Burton, and this is Ori Rawlings. Ori is going to basically walk you through a little bit of context about the company to start with, a little bit about our culture, and then we'll see some specific cases. So, Ori.
Hey. Yeah, so sounds like you guys can hear me. So we're from Orbitz Worldwide. So for those of you who may not know, we're an online travel agency. So we enable customers to book hotel, air, car, cruises, rail, attraction, and services. And we have a number of different brands internationally and a few domestic ones. So there's like Orbitz.com and Cheap Tickets and eBookers, Hotel Club. We have about, to give you a sense of the size of the business, we had customers booked over $11.4 billion in total travel last year. The Orbitz.com brand launched in 2001, and over time, the other brands were acquired. We have about 1,600 employees, and we're headquartered in Chicago. That's where all of our technology organization is. So, yeah, Chicago, all right. Yeah, so what are we talking about today? Like, oh my God, it's so beautiful. It's double capacity, right? So we had like a really interesting year last year because for quite a few years our kind of site traffic was just kind of growing incrementally a little bit. It wasn't really drastic. And then last year the business was like, we want to sign up all these new partners to our travel APIs, and we need to double capacity. And this was quite unusual for like what we had been doing in the organization. And what we kind of discovered as we started to dig into the overcoming this requirement was we had a development organization that had like a certain set of competencies and responsibilities that was working well. We had an operations team that was doing things well. But there was like all these skills and all these things that we had to do in order to solve this capacity problem that just like weren't being done by anyone. So what we kind of want to cover today is sort of how we started to like fill in that gap, span that chasm. And it's kind of the personal and organizational changes that we had to go through in order to kind of overcome these challenges. So we're going to break the presentation down into like a little bit of context on like the Orbitz technology and a little bit of like what our dev organization and our ops organizations look like. And then we're going to go through like individual technical bottlenecks in the system and the kinds of changes that we went through for each of those. So that you guys can understand how the Orbitz technology looks, I'm going to throw up this super understandable graph, right? No, I don't expect you to make any sense of this. What I kind of want to capture, though, is, for me, I think the best way to categorize what our architecture is like a microservice, I think is a good term. So we have a bunch of different processes that are all like collaborating over the network in order to provide the various components of functionality that you see on the site or in our mobile apps or in our partner APIs. One of the cool things is all of our brands are driven by the same infrastructure, so we can build once and roll it out to different businesses. Most of these individual services or apps or hosts, we might refer to them by different terms during the presentation, but most of them are implemented in some type of JVM-based technology. And we deploy into a series of co-location facilities. We have kind of a hybrid of like some stuff is on virtualization and some stuff is still on bare metal. So the other thing I want to call out about the technology is it has this big legacy component, right? So there's a lot of old code. It's seen various version control systems over the years. There's lots of things that are kind of like always mid-migration, where there's like old RPC frameworks in play, and then there's like newer preferred things, and people are always like struggling with like coping with all those challenges. You know, like different services run on different major versions of Java, and like there's all this stuff to deal with. And then the other thing is that, you know, like developers are, it's like a large organization, so there's lots of different teams. So developers move to different teams, or developers, you know, leave the company or whatever. So a lot of the code that people end up owning is like stuff that they never wrote, and sometimes they haven't even looked at it because it's not like actively developed, because it doesn't need new features. But sometimes, like, especially when you tackle a problem like this, it's like all of a sudden, okay, all these components may need a lot of work right now because we need to boost capacity. So kind of what does development look like at Orbitz, and kind of what does operations look like, or maybe traditionally kind of before this year. So development is organized into what we call feature teams. So there's embedded QA people, there's embedded product people, there's embedded engineers. And they're really focused on like end user features typically. They're, you know, building and testing those features, packaging things up into artifacts, and then like requesting that those get deployed. One of the cool things is our engineers do participate in like an on-call rotation. So as like our knock is monitoring the site, they're paging out to developers to get advice on like how we should respond and what actions to take. And then developers are like following up and identifying like fixes to those problems to keep them from reoccurring. On the other side, you know, our operations team is responsible for things like racking and bootstrapping servers and database administration, network configuration. They hold the keys to the kingdom, so they're the ones actually deploying changes. And then, of course, we have, you know, staff in the NOC that's actually monitoring things all the time. So what were the things that were kind of like not covered by either of these that was really relevant to the problem that we had to solve? So there wasn't really anyone doing like performance tuning and optimization. Like it was just kind of like, it just fell through the cracks, right? You know, nobody was doing regression testing for that. Nobody was really focused on like systematically identifying where in the infrastructure there were bottlenecks for things like capacity. And, you know, over time there were like places where things had been tuned a certain way, but, you know, things would get deployed on different hardware architectures over time, or like things about usage would change, and there wasn't really anyone following up to make sure that those tunings still made sense. There was also kind of, you know, discrete areas of expertise, of course, right? So in our organization, the development teams are scoped very much to like individual services or a small number of services. So they have a lot of expertise on like the app internals and like what features of those services are being used and how they could be changed if needed, and kind of how they interact with each other. But then on the other side, our operations team is scoped to like the whole infrastructure. They're not as focused on individual services. It's kind of a single team that supports everything. So they kind of know roughly like where in the entire infrastructure things are like breaking on a repeated basis, and there's stability issues, and like where those pressure points are. For us, that was kind of where more expertise on JVM tuning lived in the organization, but because this team was scoped to the whole infrastructure, they didn't really have the resources to go and tune like 150 or 200 different services that are running in the environment. They were kind of assuming that development teams were taking up that responsibility. And they also had like a better sense of kind of what we can expect to get out of, you know, certain hardware, and compare like discrete areas of our system and see, oh, these services can utilize this hardware and get this kind of throughput, and why don't these other services get similar throughput for like a much simpler workload? So one of the things that we did early on was we established a shared goal between the dev and ops, like across the dev and ops teams. That's to double the hotel search capacity of our site. That was kind of the particular functionality that we needed to double the capacity on. And the approach that we decided to take was to do an incremental kind of identify a bottleneck, figure out a way to resolve it, increase capacity a little bit, identify the next bottleneck, and keep moving on, as opposed to like oh my God, we need to rewrite like major subcomponents of the system and like do like more major overhauls. There was kind of a lot of suspicion that we could identify some like smaller pieces of work, do a little tuning, polish things up a little bit, and get big capacity wins. So the first bottleneck that I want to talk about, it was our database infrastructure. So this is Kaiser. He's one of our database architects. We got to work with him and his team a lot. It's quite a positive experience. But he's kind of like frustrated because during peak traffic, we were like getting alarms about CPU utilization and number of connections against the database. And he's like frustrated because there isn't budget to just like go buy a bunch of new database hardware and like scale up the database. And he suspects that there's like a lot of things that can be done in the applications to improve the utilization and kind of be gentler on the databases. But he doesn't have the kind of resources or the familiarity to dig into the applications and figure out what those changes are and like have free reign to make those changes. But he's very willing to like sit down with developers and engage them to make these types of things happen. The main way that they were doing that was by providing top query reports where they can be like, these are the queries that consume the most resources on the database. Now, what was kind of traditionally happening was like developers are like, oh, working on whatever end user features they're caring about, and then they get this report and they're kind of like, oh, yeah, that's nice. Like, here's these things that are using a lot of resources, but I don't really recognize those queries because it's in some legacy area of the code, and maybe there's like a few services that talk to the same database schema, so they're like, I don't even really know which app or service this is coming from, and but I'm kind of busy with this other thing, so I'm just gonna ignore it, right? And maybe even if I looked into it, I don't even know if there's improvements that could be made on each of those queries. Maybe they're already as efficient as possible, and it's just a ranking of what uses the most, right? So it doesn't necessarily tell you what's actionable. So the way that we disrupted that was by setting this shared goal, right? When everybody cares about doubling capacity, people stop. They can't use like, oh, I'm going to go work on this other thing as an excuse. And instead people like become enthusiastic about like rolling up their sleeves, like splunking into the code and just being like, let's go learn about this stuff that we don't know about, that we own. Let's figure out if there's opportunities that exist there. So this is what we did. We started with the top query on the report, right? And it turns out like we had no idea what it was. We dug into it. It's like some query that's being issued from like some dependent library that like nobody's looked at in a long time. All this stuff that like we weren't aware of. And it turns out that it's like the number 3 query is also from the same area of the code, and it's this like offline process where like each instance of the service, every 30 minutes it like wakes up and it has to like build these in-memory caches of like all the tax and information for the hotels and all the feed information for the hotels. So that can be like served real fast during like the online queries, right? And the way it was doing this was it was taking like all the hotels in the system and it was breaking it up into this like list of or like chunks of 100 hotels, doing a query for 100 hotels, getting the data back, and then doing that until it went through the whole list, right? And immediately there's like a few options that present themselves, right? You could be like, well, we could do this less often, like increase the period between these refreshes. Maybe that'll work. But as we're sitting with the data architects, they're like, well, maybe this made sense on older database architectures that we used to use, where it couldn't handle like really large like table scan type queries. But the new database architecture we have can actually handle this really well. And that's not insight that you would have had as a developer necessarily. But let's sit down, let's run some explain plans together. And lo and behold, it looks like, when you multiply out this like lower cost small query against this higher cost, full scan query, like it looks like it might work out to be an overall gain, an overall improvement. So we went ahead and made that change, and it works, right? So there was like a 40% reduction in CPU usage on the database, 50% reduction in connection requests. And this was like a really big first step for us because it showed that there's these really simple things that if we're systematic about identifying them in the system, we can actually maybe achieve this massive capacity increase, right? The other thing I want to call out real briefly, I'm going to go back a second, is the number 9 and the number 13 ranked queries in that report disappeared after we made this change. And it turns out there was this like really subtle like for loop bug in this batching code that caused it to do like a lookup for 100 hotels and then a lookup for one hotel. A lookup for 100 hotels, a lookup for one hotel. And this is like, there was no functional impact from that bug. So like the development team never would have discovered that. But it was these queries that had this huge operational impact. And that's a kind of a recurring theme we found. I'm going to hand it off to Greg. He's going to go through a few more of the bottlenecks that we encountered. So.
Hello again. So yeah, we found some embarrassing things. So, you know, we're showing everything today, even the very most embarrassing things, queries that shouldn't even existed. But on the flip side of that, I mean, talk about low-hanging fruit, right? Just poof, you can make things disappear. You make load disappear off the database. So that first step that Ori just described was hugely important. You can imagine our database architects were euphoric at that point. We really reduced load on the database a lot with our little collaboration. Didn't take a lot of work, and there were no trade-offs in terms of what we were offering on the feature side of things. So management was on board to keep going with this approach. Everyone who worked on it was very happy and engaged with it. So we were all getting that famous win-win-win situation you're always hearing about in DevOps. So we moved on, and we went on to our apps. Because the database was now no longer an issue. How about that when you're facing a capacity problem and you can take the database off the table? That was big. So now we're looking at our apps. And we had a problem. We had been scaling an app horizontally for a very, very long time. And we'd gotten to hundreds of instances. And we weren't getting very much out of each new instance we were adding. They were not very efficient. We had a lot of ideas on the table. You know, everybody's got a theory when something's not right, right? So this was our director of our operations center, who was feeling a little bit like this cat here. Felt like he was being buried in new instances of these applications without getting much for it. Like, why are you burying me in more horizontal scaling? The opinion is I think you're using the hardware inefficiently. I think other people are using it better. I think you can do more, and I think these things can be tuned. Now, this is just one idea of many. Sort of early on, as we're collaborating with our operations partners, we had to say, you know, we're going to commit to testing these hypotheses. Whenever someone has an idea, we're going to commit to this contract of saying, you know, we're going to validate this. We're going to decide what the best hypothesis to pursue now is and validate it. So we kind of went with this. We felt that it was a compelling argument that maybe we could get a lot out of tuning. So we want to stop here and ask the fundamental question of why something as simple as, you know, JVM tuning in apps just wasn't done all the time. I think Ori already kind of addressed this when he talked about that chasm between dev and ops. It's not that it's not obvious to do. It's just that it falls into this crack where, you know, developers are thinking, I'm focused on features. I'm sure ops has got that covered. And operations is over there thinking, we're not going to do this on 150 hosts. Devs own those things. I'm sure they've got that covered. And it sort of just falls into that range where, like, maybe it'll get done next year, maybe it'll get done next year, and it just, time goes by and it doesn't. So that's how that shared capacity goal that Ori was talking about was kind of helpful, because now ops and dev both kind of turn their gaze to that center and look and say, well, that's obvious, what's going on there? And then we can sort of approach it. Now, you know, when we talk about DevOps, we often talk about the collaborative element of it. But there's also the element of extending yourselves into the territory that you don't know as well, right? That means feature developers extending themselves into operations frame of mind, operations knowledge, and vice versa. So, you know, when you're looking at something like JVM tuning, you may at first think, there's probably somebody else who knows how to do this. Maybe they should do it. But you should quickly change the mindset and just say, why not us? Let's just do it. Let's just figure it out. And when we do it, we'll spread that knowledge. And other people can do it. So I don't want to get into technical details. It's not like rocket science. That's not what this is about. Just very basic JVM tuning, getting your spaces right. We thought we could improve the efficiency of these apps quite a lot. So off we go to production, huh? Anybody want to stop me? What did I say earlier? I said we were going to vet ideas. I said we were going to test hypotheses and not just say, well, I think this is going to be the right way to go. Let's just send it out there and move on. Back to our feature work. No, we did want to commit. Who do you think is dev and ops in this picture? I've wondered about that. Who is white-knuckled and who is really gung-ho? You know, I don't know. It's debatable. So we actually paused. Even though we had sort of an idea of what we wanted to do, we said we need a commitment to a performance testing environment that we believe in, that actually will tell us how production is going to perform, and we didn't have that as a culture. We didn't have a lot of performance testing going on. So we took the time with operations, you know, a very collaborative effort to establish an environment that we all trusted. We built it up. And before introducing any kind of changes, we said, let's just run our system as it is, really, really understand how it runs today and make sure we're happy with it. Then introduce the hypothetical change, the hypothesis. So you get a valid result that confirms or falsifies a hypothesis. And, you know, it did actually turn out to confirm our hypothesis. We did make the app a lot more efficient, as our performance testing environment showed us. And so we felt comfortable going to production at that point. And when we went to production, we were able to hit our capacity goal in terms of this application, and we reduced the overall instance count by 25%. So our operations center director is now the cat with a little less Rice Krispies, like coming up to his neck, right? This is, again, it's a psychological impact, right? You're in an organization where people see like, oh, you know, you just throw hardware at a problem, you just keep adding more, adding more, adding more. It's not increasing efficiency. It's not necessarily a smart way to solve it. And now you've got an example where you tell them, hey, we just fixed a problem, but we reduced instances at the same time. It's big. It really boosts morale all around. So let's move on to another one. We won't go through all of them, but I think this was important to look at the second one because even though we spent about 2 months on that one I just described, tuning that previous app, I want to emphasize the investments that were in that time spent. It's not all time spent just getting to that goal for that host. Look at the investments we got, because now we're about to approach another one. And we have a performance testing environment now, a real functional performance testing environment. We have this growing knowledge base of how to do this work that's spreading out across different developers. And then we have this mature relationship with operations where we have partners that we know what they know, we know when to ask them for something. When they see us coming, it's a friendly relationship. It's very, very fluid and nice. And so in this case, we're able to go ahead and tune this app in 1 week. We're able to do it all through performance testing, get it done, get it deployed. And in this case, we reduced the instance count from 110 to 16 instances. So we're doing more with less here. We're getting excited. We want to go have that beer that Devops is famous for, right? Go beer and foosball and really get touchy-feely, right? But we ran into some trouble. This time, the best laid plans did not work out the way we had hoped. We did our performance testing. We had our pre-prod environment. Everything was good and stamped. When we went to production, performance got a lot worse. We had a problem. Something in the performance testing environment did not match production and led us to an invalid conclusion. So this is really where, there's always a lot of talk about the beer and the foosball with DevOps and all those big touchy-feely moments, but it's really in these moments where the difficult ones, where something is very wrong and you've got to figure it out. This is when you go to that trust bank of DevOps and you say, all right, now we're going to really have to work together. Now let's see how our relationship is. And so maybe this can be a little bit helpful to try to help talk about how we worked with operations to face this problem, because now we've affected production. It's dangerous to roll it back because we know we can't reproduce it in pre-prod. So we're at sort of a tenuous moment. We're operating fine, but we've lost capacity. So it's not good long term. So what did we do? Guerrilla-style meetings with operations. This is not, let's have a 1-hour meeting on Thursday, and we'll get some action items, and you'll have deliverables, and have these separate tracks. This is like, let's get around your desk right now. Let's get around whoever has the best idea right now. We're over the desk. You've got your 4 monitors up. You're comfortable. You've got your log grepping going on. You've got the ideas. And we're all just chewing on ideas together. If the meeting takes 37 minutes, then that's the right length for it. If these 4 people are involved and one drops out later and another one joins in, that's a fluid meeting. That's a more effective way to have it. And being side by side like that leads to a shared understanding, ultimately, of the problem, which is helpful for getting that sort of disconnect where, operations is over here thinking it has to do with, CPU. You're running out of CPU on a certain server, and you're over here in the app side thinking your thread pools are too small, and you're just completely on different pages. And then we maintain the commitment to testing that we've said before. We've got a big haystack here. It's a big problem that's spanning across our operations and development domains. Let's shrink that haystack. Every experiment is valuable, even if the result is falsified, because that reduces your haystack a bit. So what did it turn out to be? I don't want to dwell on it too much, but we were running out of TCP connections because we had shrunk down those instances so much. We were running on much fewer host servers. So all of a sudden, these host servers were blowing up. They just couldn't maintain all those TCP connections in their tracking tables. Fairly straightforward problem once you find it. That's fine. The real question that's interesting here today is, okay, well, why was this missed in a performance testing environment? Why did I get to production without being detected? And this is where it gets kind of tricky. This is where you're spanning operations and development a bit more, because it's clearly an operations issue down at the low-level setting of a host server. But what was driving it is in the production environment, you have lots and lots of clients. And in the performance testing environment, you have a scaled-down number. But in the Tomcat application container, there is a configuration setting that changes the behavior of how TCP connections are dealt with at a certain point. And you hit that point in production, but you don't hit that point in pre-production or in a performance test environment. That setting is a pretty obscure setting. It's not something you think about when you're scaling down to a pre-prod environment to mimic production. But there it is, and it had very, very critical repercussions. We missed it in performance testing. So it's one of those things. It's a fly in the ointment, because you want to get all happy and say, like, we got our performance testing environment, we got our relationship, the world is our oyster, like the sky is the limit, right? But there's always going to be moments like this where you're going to miss something. And that's when that DevOps relationship is really important. The beers are great, but those hard times shows the mettle of the relationship. So I want to take, there was a few other things we had to do on capacity to get to that double rainbow ecstasy that Ori was talking about. But I want to take a little time to say a few words about stability. Have you guys ever seen something terrible done with a cron job in production to work around? I didn't even ask you to raise your hands, and I see people doing this, like you want to raise your hand. Horrible cron jobs that you stumble on. They've been running for 5 years, and you're the first one to see them in 5 years, and there's a comment that says, "Do not remove, this is critical." and you just want to back away slowly, cover it with dirt, and let somebody in 2018 deal with it, right? Of course he doesn't work here. Nobody who works here even remembers who it is. So those are scary things. You don't want those. These are long-standing issues in production. See, it even goes outside of our profession. Even in civil engineering, if you're painting the lines on the street, if there's a tree in the way, I don't want to move the tree, right? I'm drawing lines here. So learning to live with something that's wrong rather than fixing it, that's a culture. It develops. Sometimes it's easier to work around something than it is to actually fix it. But at a deeper level, why might that happen? A lot of these things that go wrong are operations problems. They have operations consequences. That's where they're most visible. But they may have their origins, their root cause, in a development sort of domain. So operations is in a really tricky spot where they've got something that's not easy for them to figure out. It's outside their domain. They've got to keep the site running. So you end up getting these workarounds. I want to describe one that's a little bit embarrassing. But we had a situation where our web app was degraded after 1 to 2 weeks of uptime. And it was in that state for a very long time. Now, you can get around it because we do a lot of releases. And releases restart the app, which kind of resets the clock, and everything's fine again. But it is a terrible situation to be in, to have your very, very critical web app not be able to stand on its own for 2 weeks, right? So we sort of came onto this project. It was a little bit outside of our domain, but because of our relationship with operations that we'd been developing and the other work we'd been doing, we were pulled into it to kind of help out. And the great thing was that I've been talking to you about these investments from earlier things. When we got pulled into this, we had our performance testing environment ready to go. We knew how to reproduce things. And we had that same problem reproduced in our pre-prod environment in one day, on the same day. We said, here it is. At least we've got it in the bottle, right? We have whatever we're searching for, we have it. We can experiment on it. We had all the knowledge, and we had this mature working relationship with operations. All that meant you could hit the ground running very quickly, right? At least in addressing this difficult problem. So I'd like to introduce you to Ben, the developer. He is a feature developer who worked most closely with this web app. In fact, he sort of owned it. And he didn't really have much exposure in the past to working with operations. He really stayed in the feature domain, focused on features. And so this was him sort of working with us, moving into this operations mindset. This is one of the bigger advantages also. You could even call it another investment, where knowledge is spreading around, right? Just because this group learns it, and then the culture and the knowledge start to sort of like emanate out. And so that's the direction that Ben, the developer, was headed. Now, I don't want to make it seem like this is just flipping a switch where you go, oh, hey, you're going to have an operations mindset. Come on over. Because there's more to that. I don't know, maybe some of you in the room might have experienced this, but there's sort of a guilt that goes along with taking time away from feature work. You're a feature developer, and you've been, some operations guy has like caught you walking down the hallway, and they've harpooned you and dragged you back into the operations layer. And they said, well, we've got this horrible problem. It's going to take forever to solve. Come on, let's work on it. And you have in the back of your mind, like, no, my feature deadlines are not going to change. The business is not really thinking about these operations issues. If I work on that, that's going to be invisible time. So you get this guilty phase where you feel like you have to do feature work after hours, or like still keep up on that while you're doing this other operations-focused work. That is a cultural thing that has to change. That goes all the way from management down through your peers, all the way to the business. Oh, we got an applause already.
Yeah, you can applause for that, for sure.
To view operations-driven development as productive work is really, it seems a little obvious when you say it here, but it's not the case all the time, right? Feature work is the productive work. Operations work is that thing you have to do real quick on the side, get it out of the way, and get back to the feature work. But that will kill you. You will feel awful doing that because you're just going to feel divided. You're going to feel like you need 80 hours in a week. And so we had to work through that and really get to the point where Ben, the developer, could feel like, right now I'm not a feature developer. Right now I'm doing some operations-driven development. I need to help the health of this web app that is, very important, and that is productive work. So altogether, here we went, searching this thing down. We've got our commitment to experimentation, our commitment to hypothesis testing. And we ran through tons and tons of experiments because this thing was difficult to find. We actually ended up running a total of 22 experiments. I know that number because we document every experiment very, very carefully. That is critical to do because when I'm trying to design experiment 21, will I remember what experiment 7, 8, and 9 were? Probably not. Probably I'm going to have some vague memory. But having them all laid out, documented carefully, means I can revisit them and plan out the next experiment. And that haystack just kept shrinking. And a lot of people might say, well, weren't you discouraged after the 15th, 16th, 17th test and you're getting all false results? Well, not really, because you have this sense that as long as you commit to valid hypothesis testing, you're making that haystack smaller. And so eventually we got to it, and here's the embarrassing thing. It's one line, just like all of the worst problems in the world are always located in one line of code, but it was buried in a pretty obscure place. It was hard to find. It was definitely in the development domain, so I felt really bad for all the operations guys who spent a lot of time looking for this. We were misusing a library. It had gone into the code base years before, long time, and it was just a matter of creating this object for every request as opposed to reusing it. And if you looked down inside of that, you saw that it was a pretty nasty creation. It was creating these giant custom class loaders, which had big implications for the garbage collection cycles. And so as you accumulated those, you got some bad problems. So this was extremely difficult for developers to care about because it had zero development impact or zero functional impact. It wasn't visible in any feature. It didn't cause any harm. All the harm that it caused was on the operations side. So unless you were looking, a developer turned the gaze toward the operations side and operations turned the gaze towards the development side, you're just not even going to know about this problem. You're not going to care. You're not going to address it. So, no, it's not driven really by load testing. It's not driven by load necessarily. These objects just accumulate over time, and your garbage collection cycles start to get more burdened and burdened and burdened until at some point your garbage collection cycles just take everything your app has. So you don't really see, it's not like it ebbs and flows. It's just related to uptime. It's a really nasty, weird behavior that was hard for people to track down. But there you go. You fix one line, and you suddenly make your very sick, sad web app fine, and it's healthy, and it stands up. So what are some of the key takeaways that we came through today? That shared goal between dev and ops was a really critical starting point because it meant that we weren't going to deal with each other through deliverables, and it's not going to be me opening a Jira for you, and you're doing me a favor sometime in the next sprint, and that slow, plodding pace. This is really, hey, we're in this together. We've got about this many months to get to the answer. Let's sit down. When are we going to have the meeting? Why not now? Always ask the question, like, why not now? Take that shared goal and run with it together. When you're working together with a different team, you really want to have a contract between you, like that you're going to say, look, we're all going to have ideas, and they're going to differ. We have different understandings of problems. We're going to commit to hypothesis testing and evaluation of those hypotheses to really decide what we're going to do and what we're going to move forward with. And then very, very important, from a management perspective, when you're looking at the time spent, you may say, 2 months is a lot of time to tune that one host. But you've really got to tease out the investments that were in that 2 months. What investments were there that are reusable? Because that should account for it too. You saw some of the reusable investments that I've described today. And then finally, we saw some of these bugs. The one Ori described earlier with 2 queries that didn't even need to exist were in our top 15. Please. And then the bug that I just described, which was a one-liner that was crippling our primary web app. I mean, there's some small bugs that had no functional impact at all. They did not impact any features, but they had a huge operational impact. So respect those little bugs. Don't let the little guy take advantage of you. So anyway, if you like doing stuff like this, we are Orbitz. We're located in icy Chicago, a wonderful place to live and work. And we'll be doing office hours immediately following this. So if you have any questions, we don't really have much time left, but we can do it there too. Or if anyone has a quick question, go for it.